So, first things first, we're just going to draw a diagram here. So I'm going to draw the table above the floor with the bowling ball rolling off the edge. And it tells me how fast it rolls off the edge, 3.3 meters per second. We also want to identify any other things that are given in the problem. And it also gives me 0.75 meters that the table is above the ground. So just next to the table leg, I'm going to write 0.75. I also want to draw the motion. It's going to go in a curved path. It's not going to make the triangle here yet. So don't assume it's going to be a triangle motion. I know it's easy to do that. We got it down. We got it forward. It's easy to try to make a triangle here. But it's not a triangular thing here. Lastly, it's also important to identify what forward is. You don't have to draw this necessarily every time, but I'm going to draw it just to kind of show you. Forward is to the right, and forward is down. So it goes right and goes down. So that's what I'm going to make forward. The reason that matters is that determines what positive is. Okay, so positive is right and positive is down. Then I'm going to make my X and my Y chart. Okay, first number that it gave me in the problem is 3.3. That is how fast it goes forward, so that is velocity. Forward is x, so that's 3 meters per second.
Velocity.
Or sorry, 3.3. So this is not initial or final because the x direction doesn't change, so it's just v. And that's a really poor draw, 3.3, but that's what it is, 3.3.
Mr. B, we're going to have a little math time
No.
Or we just run straight into physics like it's like...
Oh, we're just running right into it.
Flipping should be like our test.
This is a nice easy. You can listen to Mr. B do some things. All right, so distance is 0.75. That's how high it is above the table, so that's how far it's going to fall. My gosh, I'm just forgetting everything. 0.75 meters. Oh, no.
Mr. B, I would have sleep.
Okay, that's all I have as far as what's given to me. Is there anything else I know? Anything else that I automatically know for this problem? Acceleration. Is that an X or a Y thing?
I think it's the X and Y both.
Nope. Good guess, though. It's only one of them.
So, Y?
Yes. And the acceleration is what value?
9.8.
9.8.
Meters per second. No, miles.
Meters per second squared. Okay. What else? There's another thing I know for this type of problem, too. Yes. In what? The X or the Y? Yes. The up and down velocity at the beginning is 0 because it's going forward to the right, not going forward up and down. So it's going right, not up and down. So that means the initial velocity for the Y is 0. And that's all I have there for the Y direction and the X direction. So I'm ready to move on to B. How long does it take to reach the ground? So how long something takes is time.
So ain't got no time.
No, you don't want to use ain't got no time because it doesn't have time and you need to solve for time. So I got to use either the X or the Y direction. So I look at my chart and I say to myself, which do I know more information about? Do I know more about the X or do I know more about the Y? Well, I know more about the Y, so I'm going to use a Y equation. And here are the 3 Y equations. Old Faithful, Big Chalupa, Ain't Got No Time. Those are your 3 Y equations. So I'm going to use one of them. So I need an equation that's got D-A-V-I-N-T. So D-A-V-I-T. Yes, Big Chalupa has what I need. So I just set it up. So D equals VI. Now, I need the Y initial. I'm using Y stuff, so I need the Y initial, so that's 0. VIT, 0 times T, so it's 0 anything, is 0, plus 1/2 times A times T squared. So, half of 9.8 is 4.9 times T squared. Divide the 4.9 to both sides. When you do that, 0.75 divided by 4.9, you get 0.15. But that's equal to T squared, and I want just T. So I got to do the opposite of squaring, which is square rooting. And I get T equals...
Is it 0.38?
.39.
Do we have to round it, or can I just say 0.38?
That's fine. There we go. There's the time. Yes, and this is the time for both the x and the y, so I can get rid of my unknown for t. And that's for both the x and the y. Okay, how far out from the edge of the table will it land? So we're solving for dx. How far forward will it go? Okay? So I need to solve for d in the x column. So I only have one x equation, v equals d over t. So v, I need to use my xv, which is 3.3, equals d. I need to use my xd, which is unknown, over t, which is 0.39. I'm going to multiply both sides by 0.39. Yep. I got 1.29, but it's close enough. Okay. D is 1.29 meters. Okay. Look at us being 3/4 of the way done. Okay. What is the resultant velocity and the angle of the bowling ball right before hitting the ground? So, I have, at this point, right before I reach the ground, some downward to the right velocity. So it's falling down and going to the right.
Wouldn't it be 0 if you're touching the ground?
It's right before it hits the ground.
Wouldn't it be 3.3 meters per second squared?
Close.
3.3.
So, it's going down and to the right. That down and to the right is made up of a forward velocity, which Cannon already said, 3.3 meters per second. And it's made up of a downward velocity. That I don't know. That's my final velocity for the y direction. I don't know what that is. So, first thing I need to do is find that final velocity. I'm going to do that using my y direction and I can use any equation in the y direction that has v final. So Old Faithful has v final. I'm going to use that one. So v final equals v initial plus at. Gives me 8.82. No, that's not right.
3.8 facts.
That sounds much better.
So, Mr. B, are you on the breakfast one?
Nope, just putting in wrong numbers.
It's a Monday. Let's just blame it on that.
Okay.
So now we know how fast it's going in the up and down direction.
But wasn't Monday when
And so that's what this value is here, 3.822. But that's not what I'm finding. It didn't ask for the y velocity. I just had to find that first. It's asking for the resultant velocity. So the resultant velocity is this here.
Mr. B, I have something crazy to tell you.
Oh, yeah?
A squared equals b squared equals c squared.
That is pretty crazy, and it is correct. So what I'm going to do is I'm going to solve the triangle. And the way I solve the triangle is by doing a squared plus b squared equals c squared. So a squared is 3.3 squared plus b squared, 3.822 squared equals c squared. And c is that velocity that we're solving for there.
that's a lot of math. I gotta think this hard for tomorrow. So thank you.
You're welcome. 25.49, let's round it to 25.50, equals c squared. I need to square root that number. I get that velocity c is 5.05 meters per second.
5.05.
Mm-hmm.
I'm not even gonna try to figure that out.
Well, you need to know how to figure it out.
Yeah, that's it.
So we've got the velocity now. All that's left is to find the angle theta.
That's
And that's this angle here. We do that by doing tangent. So tan -1 of b over a. So I do tan -1, so theta equals tan -1 of b, which is 3.822, over a, which is 3.3. So 3.822 divided by 3.3 is 1.158. Yes.
How do you tell, wait, what was it, 1.158? How do you tell which one's A and which one's B?
Good question. So the way you figure out which is A and which is B is by looking at this triangle up here. So A is always the horizontal flat one. B is always the vertical straight one. And C is always at an angle. So when I look at mine down here, so C would be this one here.
I got the
A would be this one. B would be this one.
Is A the shorter one usually?
Not always.
See, I can't figure out which one's A and which one's B.
A is like this.
So the one it's standing on.
Sure, but it could also, like on this one, it's above it. But yeah, it's the side to side one. A is always the side to side one, and B is always the up and down one.
Okay.
Okay.